Dear students, in this session we will discuss about electrical resistivity method. Electrical resistivity method, as you know that this is also a type of method used for groundwater exploration. To identify the borehole point, we have to conduct geophysical survey. For this, the electrical resistivity method is the easiest. That's why this we'll discuss. Electrical resistivity methods, electromagnetic methods, self-potential methods, and induced polarization methods are the important categories of electrical methods. All geological formations have a property called electrical resistivity rho, and this resistivity is expressed in the units of ohm meters. The various geological factors which influence the electrical resistivity of the subsurface formations are mineral content. Most of rock forming minerals have high resistivity except sulfide minerals. Compactness, moisture, salinity of moisture, texture of the rock can be identified. Resistivity or inverse of electrical conductivity is a measure of the capacity of a rock to allow an electric current through it. Dry rocks and sediments, dense, compact, and non-porous rocks will offer a greater resistance to the electric current compared to loose, porous, and wet saturated materials. There are two variations of the resistivity method. One is profiling method, that is lateral exploration. Second is sounding method, that is the vertical electrical sounding, that is VES. Electrical profiling. Electrical profiling or transversing is done to detect lateral changes in resistivity which reflects the surface lithology in a large area up to the same depth. Whereas electrical sounding is done to determine vertical changes in resistivity which reveals the change in lithology at a particular place with increasing depth. In profiling or sounding, there is scope for electrode arrangements to be made in different ways in the field, as such arrangements are called electrode configurations. The two main methods which are commonly used are Wenner configuration and Schlumberger configuration. Look at the screen. The picture shows, arrangement shows the Wenner configuration. The inner P1, P2 are the potentials, and the P1, P2 are inner potential, C1, C2 are the outer potentials. We pass the voltage through the P1, P2, and we'll get the current I through C1, C2. In this method, the method was developed by Wenner in 1915. In this configuration, the outer electrodes C1, C2 are used to send current into the ground, and the inner electrodes P1 and P2 are used to measure the potential. The electrodes are inserted in the ground and connected in a circuit to a source of electrical energy. As the current is introduced, it travels from one electrode, passes through the material, and leaves the ground at the other current electrode. In between, the current will meet resistance from the material and there will be a drop in its potential. This drop in potential is measured by potential electrodes. The important feature of this setup is that the distance between any two successive electrodes is equal. The apparent resistivity measured in the Wenner method is uh, given by rho A is equal to 2 pi A R, capital R is equal to 2 pi A V by I, where A is electrode separation, V is potential difference measured, I is current sent into the ground, rho A is apparent resistance, that is in ohm meters. In this system, all four electrodes are shifted and moved simultaneously for each reading, starting with small separation of 1 to 2 meters and expanding up to hundreds of meters. In the next session, we'll discuss about the Schlumberger configuration. Thank you.